There is a category of person who exercises regularly, eats reasonably well, maintains a healthy weight, and still has measurably worse metabolic health than someone who does none of those things but simply does not sit for extended periods. This sounds wrong. It contradicts the basic logic of how most people think about health. That exercise is the active variable, that what you do in the gym determines your metabolic fate, that the rest of the day is neutral. The rest of the day is not neutral. Research over the past 2 decades has established that prolonged sitting is an independent risk factor for metabolic disease, cardiovascular disease, and early death, independent of exercise. Not attenuated by exercise, independent of it. A person who runs 5 kilometers every morning and then sits for 9 hours is not protected from the metabolic consequences of those 9 hours by the 5 kilometers. This is not about posture. It is not about back pain or hip flexor tightness, though those are real. It is about a set of metabolic changes that occur at the cellular level when muscle tissue is inactive for extended periods. Changes that do not wait for exercise to reverse them and that compound over hours into a pattern of physiological disruption that no amount of gym time fully corrects. Understanding the mechanism changes what you do about it. Not more exercise, different behavior distributed through the day. The first mechanism, and the one most directly responsible for the metabolic consequences of prolonged sitting, involves an enzyme called lipoprotein lipase, or LPL. Lipoprotein lipase is produced primarily by muscle cells and fat cells and is deployed on the walls of blood vessels where it performs a critical metabolic function. It breaks down triglycerides, the fat particles circulating in the blood, and facilitates their uptake into tissues for use as energy or storage. LPL activity in muscle is the primary mechanism by which the body clears blood triglycerides after a meal. When muscle LPL is active, triglycerides are efficiently removed from circulation, blood lipid levels remain normal, and the metabolic machinery of fat processing functions as intended. When muscle is inactive, specifically when the large postural and locomotor muscles of the legs are not contracting, LPL activity drops dramatically. Research by Mark Hamilton at the Pennington Biomedical Research Center found that LPL activity in leg muscles decreased by approximately 90% within 90 minutes of the muscles becoming inactive. Not 90 minutes of sitting per day, 90 minutes of continuous inactivity in a single stretch. This is not a gradual decline. It is an almost complete shutdown of a major metabolic pathway within an hour and a half of not using the muscles that pathway depends on. The consequence is immediate and measurable. Blood triglycerides rise. The lipid that would have been cleared by active muscle LPL remains in circulation. Over the course of a day of extended sitting, triglyceride levels in the blood can be meaningfully elevated compared to a day with the same caloric intake but regular postural movement. Elevated triglycerides are not a trivial concern. They are a primary driver of cardiovascular risk, contributing to the formation of arterial plaques, promoting insulin resistance, and driving the low-grade inflammation that underlies most chronic disease. The person who sits for 8 hours straight is not burning fewer calories than they would have standing. They are running a metabolic process at 10% of its normal capacity for 8 hours. The second mechanism involves blood flow, specifically the dramatic reduction in blood flow to the lower extremities that occurs with prolonged sitting. When you sit, the major arteries supplying the legs are partially compressed. The muscles of the legs, the largest muscle mass in the body, are not contracting, so the muscle pump mechanism that assists venous return is inactive. Blood pools in the lower legs. Venous return to the heart decreases. And the endothelium, the thin layer of cells lining the blood vessels, responds to the reduced flow in a way that has long-term consequences. A study published in Experimental Physiology measured blood flow through the popliteal artery, the major artery behind the knee, during prolonged sitting. After 2 hours of continuous sitting, blood flow had decreased by approximately 50% compared to standing. 50% reduction in blood flow through a major artery in 2 hours. But the more significant finding was what this reduced blood flow did to the endothelium. The endothelium responds to blood flow, specifically to the shear stress that flowing blood creates on vessel walls, by producing nitric oxide, the molecule that keeps vessels dilated, prevents clot formation, and maintains vascular health. Reduced blood flow means reduced shear stress means reduced nitric oxide production. The vessels become less responsive, less flexible, and more prone to the dysfunction that precedes cardiovascular disease. The researchers also found evidence of endothelial impairment, a measurable reduction in the vessel's ability to dilate in response to stimulus after just 2 hours of sitting. Not 2 years of sedentary lifestyle, 2 hours of continuous sitting in an otherwise healthy young adult. A brief walk, 3 to 5 minutes, restored blood flow and reversed the endothelial impairment. The damage was not permanent, but it recurred with the next extended sitting bout. And for most people in modern work environments, sitting bouts are not isolated events. They are the dominant pattern of the day. The independent nature of sitting as a risk factor, the finding that its effects are not canceled by exercise, requires some explanation because it is counterintuitive. Exercise produces adaptations in cardiovascular fitness, insulin sensitivity, muscle mass, and numerous other health parameters. These adaptations are real and substantial. A person who exercises regularly has meaningfully better health outcomes than a sedentary person by almost every measure. But exercise does not maintain LPL activity in muscle during the hours when muscle is inactive. LPL activity is not a chronic adaptation that persists from a morning workout throughout the rest of the day. It is an acute response to muscle contraction. Muscle that is not contracting has low LPL activity regardless of how recently it was exercised. Similarly, the endothelial effects of prolonged reduced blood flow occur in real time during the period of reduced flow, not as a function of the individual's fitness level. A fit person sitting for 8 hours experiences the same reduction in popliteal artery blood flow as an unfit person. The endothelial response to reduced shear stress is the same. The LPL shutdown is the same. This is what researchers mean when they say that sitting is an independent risk factor. It is not that exercise has no protective value. It does, substantially. It is that the specific mechanisms through which prolonged inactivity disrupts metabolism operate during the inactive period itself, and those mechanisms are not overridden by exercise that occurred hours earlier. A study published in the journal Medicine and Science in Sports and Exercise followed a large cohort and found that time spent sitting was associated with increased mortality risk independent of leisure time physical activity. People who sat for more than 6 hours per day had significantly higher mortality rates than people who sat for less than 3 hours, even after controlling for exercise habits. Among those who exercised regularly, sitting time still predicted mortality, though the association was somewhat attenuated. The implication is not that exercise is useless, it is that exercise and reducing prolonged sitting are not substitutes for each other. They address different mechanisms. Both are necessary. There is a glucose metabolism dimension to prolonged sitting that connects directly to everything discussed earlier about insulin resistance and metabolic disease. When you eat a meal and blood glucose rises, the primary destination for that glucose is muscle. Muscle that is actively contracting, or that has recently contracted, is particularly efficient at glucose uptake, partly through insulin-dependent mechanisms and partly through the insulin-independent mechanism involving glucose transporter proteins activated by muscle contraction. Sitting immediately after a meal, which is what most people do, having eaten at a desk or table and then return to sitting, places the glucose disposal burden entirely on the insulin-dependent pathway, with none of the enhancement provided by recent or ongoing muscle contraction. Post-meal blood glucose spikes are higher. The insulin response is larger. The metabolic clearance is slower. A study published in Diabetologia tested the effect of breaking up sitting time with brief walks after meals. Participants who took 3-minute walks every 30 minutes had significantly lower post-meal blood glucose and insulin levels compared to those who sat continuously, even though the total caloric intake was identical and the amount of exercise was minimal. 3 minutes every 30 minutes. The metabolic difference was not trivial. It was comparable in magnitude to the glucose-lowering effect of a moderate aerobic exercise session. This finding has direct practical implications. The glucose processing that occurs in the 2 to 3 hours after a meal is where a significant portion of metabolic health is determined. Whether that processing happens in a context of muscle activity or muscle inactivity produces meaningfully different outcomes, not because of the calories burned in the activity, but because of the molecular machinery that muscle activity keeps switched on. The body was not designed for prolonged static postures. This is not a philosophical statement. It is a description of the evolutionary mismatch between human physiology and the modern work environment. Human locomotion and postural variability. Standing, walking, squatting, shifting position were the baseline conditions under which the metabolic machinery of LPL activity, vascular shear stress, and glucose transport developed. These systems were calibrated for an environment in which extended periods of complete muscular inactivity simply did not occur during waking hours. The chair is a recent invention in evolutionary terms. Sitting for extended periods at a desk for 8 or more hours is a pattern that has existed for a tiny fraction of human evolutionary history. The metabolic systems that regulate fat processing, blood flow, and glucose metabolism did not adapt to this pattern because the pattern did not exist long enough to drive adaptation. This mismatch is why the metabolic consequences of prolonged sitting are so immediate and so significant. The LPL shut down within 90 minutes, the 50% reduction in blood flow within 2 hours. These are not pathological responses to an unusual stressor. They are normal responses to inactivity that, in the ancestral environment, inactivity this complete and this prolonged simply did not happen. Here is what the research supports practically. The intervention with the strongest evidence base is also the simplest, interrupting sitting with brief movement at regular intervals throughout the day. Not replacing sitting with standing, the evidence for standing desks as a meaningful health intervention is much weaker than commonly claimed, partly because standing without movement does not restore LPL activity the way muscle contraction does. Moving, briefly, regularly. The intervals that appear most effective in the research are somewhere between 20 and 30 minutes. A break of 2 to 5 minutes at this interval, walking to another room, taking stairs, a brief series of bodyweight movements, is sufficient to restore LPL activity, partially restore blood flow, and maintain the glucose disposal mechanisms in a more active state. This does not require a standing desk, a treadmill desk, or any equipment. It requires a timer and the habit of responding to it by getting up and moving briefly before returning to work. Walking after meals is the highest leverage single behavior change supported by the research. The post-meal window, the 90 minutes to 2 hours after eating, is when blood glucose and triglycerides are at their peak and when muscle activity has the greatest metabolic impact on how efficiently those substrates are cleared. A 10 to 15-minute walk after eating produces measurable reductions in post-meal glucose and triglyceride levels that persist for several hours. The evidence on total daily sitting time suggests that keeping total sitting to under 6 to 7 hours per day, for most office workers, this requires deliberate effort, is associated with substantially better metabolic and cardiovascular outcomes than exceeding this threshold. This does not require standing for the remainder of the day. It requires distributing movement throughout the day rather than concentrating all activity in a single exercise session. Here is the synthesis. Prolonged sitting is not the absence of exercise. It is a distinct physiological state with its own metabolic consequences, consequences that occur in real time during the sitting itself through mechanisms that exercise does not address because exercise and sitting are not on the same continuum. They are separate variables. The person who exercises for 1 hour and then sits for 8 is not in a neutral metabolic state for those 8 hours. They are running their fat processing metabolism at 10% capacity, reducing blood flow to their lower extremities by 50%, impairing the endothelium that keeps their vessels healthy, and managing post-meal glucose without the benefit of muscle contraction that makes that management most efficient. None of this is permanent. The effects reverse rapidly with movement. The damage is not cumulative in the way that smoking damages lung tissue. But it recurs with every extended sitting bout, accumulating over years into a pattern of metabolic load that has measurable consequences for disease risk. The solution is not heroic. It is a timer and a 2-minute walk every half hour. It is a 10-minute walk after lunch. It is the habit of treating sitting as something to interrupt rather than a default state to maintain for as long as possible. The body was built to move, not to exercise, to move, briefly, regularly throughout the day. That is the pattern the metabolic systems were calibrated for. Recovering it does not require a gym. It requires not sitting still for 90 minutes at a time. If this changed how you think about what happens to your body between workouts, hit the like button. Share it with someone who sits at a desk all day and thinks their morning run covers it. And subscribe for more content like this.